Oh, hello. I thought I'd slip another one in here and give you an idea of how to use some of the technologies. Now, most of this is going to probably refer just to the TI-84, but I'm guessing that if you have a TI-Nspire, you'll be able to follow this anyway. And first, we'll make sure the pen's rolling here. Test down at the bottom. There we go. We're ready to roll. Let's go. Alright, just a note, you've seen this one before about the stat wizards. You really probably don't care, you just want to use them. Some of the old ones. Now this is the important part right here. The invT option. It represents inverse T distribution so what you should do is, if you have a TI-83 or 84, just double check, go to, well, you could check the OS, which would be second memory, and just look at the top, hit number 1, you'll see which one it is. What you should do is check a place you've been a lot of times so far. Go to second distribution and see if you see that inverse T function available to you. If you don't have it, which will probably be rare cases, and most likely only those with TI-83 calculators, what you need is a T table. And there are two easy ways of getting it. Number one, you could just take a picture from the appendix in the back of the book. Oops. Picture. Second, you could go to the internet. Just search for a T table, print it out, and you'll have it. The third thing you would need to do is learn how to use that T table. Now, it isn't very difficult. Across the top, you'll have various numbers like this, actually more like 0.5 or something like that, across the top. And down here in this column, you'll have something called degrees of freedom. By this point, you probably know that degrees of freedom is just n minus 1. One less than your sample size, and you'll be in business. Or another option actually would be to see if you can borrow someone's calculator occasionally when you want to do that. That's a possibility, because T distributions are different from the standard normal, which you could also call the Z distribution. So here you go. Find the value of T, and sometimes you'll see that as T sub C, because it'll be a critical point, and you can test this out for yourself, see that you can do this. 17 degrees of freedom, that means N was 18, because degrees of freedom is one less than that. You want the area under the curve to the left of T. So if the area is only 0.10, that would mean you'd have to be there to get an area that small. And there would be your T. And it's a bit like the old one, the Z one. Zeros here, that means this one would have a negative value. So go to second bars, go to the distribution menu, choose option 4 for inverse T, assuming you've got it, or go to the table. And this is what numbers you need to put in. First of all, put the area to the left of T, degrees of freedom, which will be n-1. So for this particular example, there's our inverse T, there's our area, there's our degrees of freedom, hit enter, and there you go, negative 1.333. Now this is negative, just like I said it would, because that area is on the left and it's very small. And the picture there is what you would be likely to see on your TI-84 of any variety, actually. Well, that's about it. Let's move on. Confidence intervals. Now, we've already talked about that in class. And first of all, we're going to talk about the Z interval. That's if you know the standard deviation, as opposed to T, an unknown standard deviation. So first of all, the Z interval, they're very close to each other too. So let's suppose you want to find an 85% confidence interval for the mean amount of money teachers spend on lunch each day. So here's the setup. There's n equals 42. That's your sample size. And you found from your sample that $18 is the average. And since that's from a sample / survey, X bar would be 18. And you also happen to know from historical purposes, most likely, that the population standard deviation is $2 per week. Now that means, since you know this, that you'll be using a Z interval. If you had found this from your sample, then this would be S, and you'd be using a T interval. But in this case, we've got the Z interval. So how do you solve it? Go to Stat, move over to Tests. In fact, the shorthand, the way I do it, is when I hit Stat, then I'll do a left cursor. It takes me right to the Tests menu. From the Test menu, choose number 7 for Z interval. This is going to be so easy, you won't believe it. Make sure you choose stats, because we didn't have the original numbers. We have the stats. Then press enter. Now you might see data highlighted, in which case you move over to stats, hit enter to activate that, then put in your 2 for the standard deviation, 18 for X bar, sample size of 42 for N, and 0.85 for the level of confidence you want. Go down to calculate, hit enter, and that's what you should see. Next, the way to answer that question is like this. So you might want to copy this down. In fact, I know this sounds terrible, but you might want to write that down several times just to get the wording down proper. We are 85% confident, that's how you start the wording, that the mean amount of money the teachers spend on lunch each week, that's what you're looking for, is between $17.56 and $18.44. That's really good wording. So if you're keeping a 3x5 card, 4x6 card, or some kind of a page with some notes on it, You might want to write that down as one of your notes, because I like that kind of wording. Notice when the population standard deviation is unknown, so this is a new story. When we knew it, it was a z-interval we were finding. But if it's unknown, then you're going to use a critical value of t instead. Make special note of that. Put it in red, green, whatever, something big, maybe put a star by it, whatever you need to so you don't forget. So what you're going to do this time is you go to stat, and then you go over tests. This time though, you're going to choose, there we go. You're going to choose 8 for the t interval because the standard deviation was unknown. So here's our example. You're given a sample standard deviation. Notice you didn't know the population one. That means immediately you're on T alert, shall we say. That means this is S, not sigma. You don't know this, and you enter the data like this. Make sure that stats is highlighted. If data is highlighted, move over here, hit enter, and stats will be highlighted. Then put in your X bar, your sample standard deviation, the size of your sample, and of course your confidence level. Down to calculate, and then you'll hit enter. And this is what you should get. If you didn't get it, rewind a little bit, try it again until you get the 17.473, 18.527, or thereabouts. If you can't find that on your TI-Nspire, come check with me. We can find it pretty quickly. But I think you won't have too much trouble. Of course, you always start the menu, go to stats, and from there on distribution, because you're talking about that, or tests, I forget. You'll find out. Okay, here's an example for you to try. First of all, you want to write down some of the essential details. 95% means C is 0.95. Remember, that's in the middle. So like this, you got a survey of 12, so N equals 12. From that survey, you got the $20. That means X bar equals 20, and a sample standard deviation, that means S, is $3. Go to stat again, we're back to tests, whatever. Number 8 for T interval, because you're using the sample standard deviation. Choose the stats. Don't accidentally have the data highlighted. You'll get a strange looking menu if you do. Enter 20 for X bar, 3 for S, 12 for N, 0.95 for level of confidence, and down to calculate where you'll hit enter. And you should see something like this. And there's some good wording for you. If you didn't get the previous one, the wording is basically the same, just the numbers are different because the numbers were different. It's a different sample. This one's a little bit goofed up, but I think you can tell what it is. I just didn't fix this one. So this stat that you see here should be there. So it says to begin, press stat, scroll over to tests. It's the same deal. We've been there a couple of other times already. Now this one's for population proportions. So this one's different. Number 1 was for the mean, where you knew the standard deviation. Number 2 was for the mean, where you didn't know the standard deviation. And this one is for the population proportions. And we're talking about P. So, stat, tests, what you want this time is one proportion Z interval. The only values you need are the sample size, N, the number in the sample, and you need X, and you need, where is it? That's it. You need those. And the confidence level, of course. So you need N, you need X, those give you the proportion, and we've talked about that in class. This will give you a point estimate, P hat, and that's X over N, but actually the calculator will give you that as well, or calculate that and do all the rest. And you need to put in C. 0.95, 0.99, or whatever you need. So here's the example for you to play with. You've got a survey of 345, and there's your N. They found the 301 students, that's your X. And they found there wasn't enough parking on campus. How confident do you want to be? Well, this time we're going to use 90%. So go to Stat, Tests, oops, there we go. And you're going to use one, see, I think it was A1 proportion Z interval. Put in the numbers N, X, and C. There you go with the steps. And it should look something like this. Alright, so we've gone through all three for the technology that you have. And if you have any questions, bring them to class. We'll take care of those. And this is what you should have gotten. And we'll see you next time. And by the way, speaking of next time, we'll pretty soon be hitting hypothesis testing, where we'll use some of these confidence intervals and we'll do something a little bit different. But it all ties together. So, I'll see you next time. Goodbye.